Everybody, please give our today's presenter, Nirmal, a big round of applause. Welcome.
Hello, everyone. Today, I will be covering some key points in this talk regarding cybersecurity and Python. We'll look at how threat actors can target your systems or networks and some common attack and defensive strategies and testing approaches. I will also share approaches to help you keep secure your application and Python's role in all of this. Finally, I will wrap things up with a real-life example where Python was used to detect and exploit a vulnerability for a good cause. Through this talk, my only goal is to highlight how Python could be used in and is being used by cybersecurity professionals in defensive and offensive security. Because most people, when we say Python, they think of either real Python or a web data science, web application, ML, or AI, but do not think of cybersecurity immediately. So as someone who has been in this cybersecurity field for a decade now, I can say that the Python is here and there in cybersecurity and is being used by professionals for a long time for various uses like automating, scanning, detecting, exploiting, alerting, and more. So that is why my talk's title is Python-powered cybersecurity, tools, techniques, exploitation, and automation. But before that, little about myself. My name is Nirmal Dahal. I am from Nepal, and I am co-founder of CryptoZen Nepal, which is Nepal-based cybersecurity firm that is listed in Cyber Alliance's top 250 managed security service provider list for the last 2 consecutive years. And as I said earlier, I have an almost a decade of experience in this cybersecurity and information security field. And you can connect me on these sites. So first of all, I hope you all are familiar with the cybersecurity norms, right? OK, so anyone can answer what is cybersecurity? No? OK, well, it is a practice of protecting your digital assets, right? Assets connected to the network from cyber attacks. So network can be public or private. It could be anything, right? So by meaning digital assets, so what do you think I am referring to? Anyone can answer? Well, it could be your web application. It could be your APIs. It could be your mobile application. It could be your servers, IoT devices, cloud infrastructures. And all of these can be vulnerable and always have a chance to get attacked, right? So there comes the concept of offensive and defensive security. So for your understanding, here we have a private and public network. The common area in between is known as DMZ, the delimiterized zone. Then we have got cloud infrastructure. We have deployed all of our applications here, mobile applications, server, API, and all others, right? And we got few users here. They can access these publicly accessible digital assets anytime. And one of these users could be an attacker. Let's say he's jealous of our success and trying to exploit our publicly facing application, like web application, to gain access to our internal network and steal our business strategies. So to be secure and with this type of threat actors, we can deploy our offensive security expert there. This person's role is to act like an attacker, attempting to find vulnerabilities in our digital assets and report them to us. So we can secure our application, and this is known as the offensive approach, offensive security approach, right? So, and if And we can also have a team focused on continuously monitoring, collecting logs from these digital assets, identifying potential attacks, and preventing attacks from accessing our network. And we call them defensive security experts who work with the defensive approach. So this is the differences, or you can also see the differences here. So if we compare these differences between offensive security and defensive security, which is also shown in the screen, the offensive security is often called as ethical hacking or red teaming that requires thinking like an attacker. And this means simulating attacks to identify vulnerabilities, right? On the other hand, in the defensive security, or known as blue teaming, requires having a defender's mindset. This focuses on monitoring and defending against attack and potential attacks. But both roles have a methodologies and standards to follow. You can not just go and randomly attack sites or anything like that. Okay, so we do have methodologies that we must have to follow. And here we can use Python, and Python can be valuable throughout almost every stages and process of these helping to get cybersecurity professionals get their job done efficiently. So if we more talk about offensive approaches, you can see vulnerability assessment, red teaming, bug bounty. These are some common approaches and most heard offensive approaches, right? So as I already mentioned, as an offensive security team lead or security guy, our main goal is to find vulnerability before the malicious actors do. So, however, regardless of what approach you follow, looking for vulnerabilities randomly is not effective. So, to be successful, you need a structured approach and comprehensive information of the target. And for that, one of the most widely used approach in offensive security is vulnerability assessment and penetration testing. This methodical process contains generally 6 key stages, and each stage plays a crucial role, and Python is something that often handy throughout all of these stages. So these are the stages. The first one is information gathering. The second one is threat modeling. Third, vulnerability assessment. Fourth, exploitation. Fifth, post-exploitation. And the last one is reporting. So in the information gathering, the tools like these all tools are Python-based. Okay, so so tools like tools like ReconNG, the harvesters, and sublisters help gather data about the target. So if you use ReconNG or sublister, it will show you the subdomains of the target. It can also help you with identifying the CMS that the target is using. That will also help you with the other ports and the services that the server is currently hosting. So you can use these tools in the first stages. In the second stages, threat modeling, you can use either PyTM or ThreatSpec, and these tools can help you identify and prioritize attack vectors. And we have in this third phase, so it depends, by the way. If you are testing for the web applications, you can use web application attack and audit framework, which is for web applications especially. It will help you with detecting vulnerabilities. It currently supports 200+ vulnerabilities, so you can easily identify the vulnerabilities, right? And you can also use MobSF for mobile application penetration testing. And the MobSF is also based on Python, so it is on the top of Django. And for exploitation, so suppose you get SQL injection in the vulnerability assessment phase, you can use SQL map to exploit it further. Or if you have any network-related flaw, you can also use Impacket, which is also a collection. And for exploitation, you can use C2C server like Empire, TrackMap EXE, or NetEXEC as well. And for the reporting part, you can use Faraday, which is also a Python-based tool. So if we see, we can use Python for all of these offensive security approaches. And these are just a few tools that we used for each stages. There could be other tools as well, but Python supporting offensive security experts at each phases here. And this is what I wanted to highlight from my findings, vulnerability to reporting them. Now let's look at the defensive security approaches. So as you can see, these are some commonly discussed approaches in defensive security. If you closely look, you will notice detection and response appear too frequently here. That is because in defensive security, mean time to detect and the mean time to respond are critical matrices. With our previous slide, you can now relate that for an attackers, finding just one loophole is enough to compromise the entire system. But from the defender's perspective, you are dealing with complex landscape, countless servers, network devices, technologies, and web applications, and mobile applications, and more, right? So you simply cannot depend on human capabilities to monitor and detect each and every attack. So there comes the automation, and for the automation we can use Python. So let's understand this with an example. So imagine you are on vacation and suddenly your systems are getting attacked. If you were at your office, you could quickly block the malicious IP, but in this situation you are not available to respond. So here the open source tool can be helpful. So there is one XDR solution like Waza that offers active response. So here in active response, you can write a Python script that uses various libraries to analyze log and trigger actions like blocking IP addresses automatically based on the analysis result. So similarly, you can craft your Python scripts to prevent attacks. Likewise, you can build your own automated responder using Python that can okay, sorry. You can build your own automated responder using Python so that even when you are not available, Python enables you to automate critical security responses, keeping your systems more secure without relying on human interventions. But Python doesn't stop here. There is more with Python in defensive security, like generating custom reports, send email alerts, even you can send trigger SMS for critical security incidents. You can integrate with threat intels and many more. So these are few examples of how Python can be leveraged in defensive security. Now let's have a look few common and useful libraries in cybersecurity for both defensive and offensive. So you can see request. We can use request module for testing APIs, and we can use request module for the custom request and handling responses. We can also use Beautiful Soup for information gathering. You may scrap emails or something like that stuffs. And you can also use a regular expression or a module called RE for pattern matching and such kind of things. You can also use JSON. JSON is also can be used for the API penetration testing and such things. If there is some attacks that is related to network, we can use SCAPI and Impackets. So, and for the cryptographical security related issue, we can use Haslib and Best64. And there are so many libraries we can use, and these are few from all of these. So here I have one real life example that we faced a few years back. Our team was provided with a scope, let's say a scope of client X, clientx.com. Then we found a vulnerability that requires 3 or 4 requests to exploit and upload a backdoor to the system. We noticed footer note crafted by XYZ tagged in the footer of that site, indicating the application was developed by a vendor, which is quite popular. So, suspecting the same vulnerable plugin might be used somewhere else, so we conducted a Google search. From the Google search, we got so many sites developed by the same vendor. However, due to ethical consideration, we could not check other sites, so we focused only on our client site. But we realized that manual pen testing each site would be too time consuming, so we decided to build automation. So we wrote a Python script here where we simply input our URL of the target and the script handle REST. So from confirming the vulnerability, REST, so REST means from confirming the vulnerability to exploiting it and uploading a backdoor with a random generated file name so that we can avoid detection from external parties. Then we reported the vulnerability to our clients, and then the vendor fixed the vulnerability for all of their clients. So this case highlights how much Python can be helpful to automate offensive security tasks. And this was the simple script. It was only 27 lines long. So as I mentioned earlier, I had included request, JSON, string, and random libraries here. And this is Python in action. You can also read. I simply provided the URL. Then it created a file first. Then it put the backdoor in that file. Then it lastly outputted the final URL of with backdoor. Then you can now access the server remotely from the client. So if I was an attacker, I could execute any system command remotely, or even I could take SSH like shell in my local machine after that. So yeah, this is all about this slide. So if you have any question, you may ask, or we may meet outside the session. Thank you.